Hello everyone, welcome to today's session on real numbers. So in real numbers, we will look at revisiting the irrational numbers. So in earlier session, we learned what are the rational numbers and irrational numbers. So the rational numbers are in the form of P by Q. Rational numbers are in the form of P by Q, where Q is not equal to 0. So if any numbers that do not obey this rational numbers principle, those are irrational numbers. So the irrational numbers, the examples are like the value of pi, right, which is 3.14, and root 2, root 3, root 5, root 11, and so on. So these are irrational numbers. Okay. Now let's see how to prove a particular numbers are. See, there is a theorem. Okay. Let p be a prime number, right? If p divides a square, then p divides a, where a is a positive integer. So let p be a prime number if p divides a square. Let's say p is a prime number, let's say 2, and a is some number, some integer, let's say that is 4. Okay, so if p divides a square, then p divides a as well. So let's see this. What is a square by p? So if p divides a square, p divides a as well. So what is a? Is 4 square by 2. That is 16 by 2. That is 8. Now it should divide a. The p should divide a as well. So what is a? 4. 4 by 2 is 2. So this theorem states that the p, if p any prime number that divides an integer a square, then that also divides a a. Okay, so that's what we need to learn. So this we can apply in our next proofs. Okay, so here let's prove root 2 is irrational. Okay, so here I'll follow a contrary method, right? So what I will say as, I'll assume root 2 as rational. Okay, so let us assume root 2 is rational. I know this is not true. I'm assuming this is a contrary to root 2 is irrational. Okay, we'll see what happens if I assume root 2 as rational. If root 2 is rational, what will happen? I can write root 2 as any coprimes a by b, where b is not equal to 0, and a comma b are coprimes. Right? Now, can I write this as root 2b equal to a? If I square on both sides, can I write as 2b square equal to a square? Right? So here, b square can I write as a square by 2. That means 2 is dividing a square. If 2 is dividing a square, 2 should divide a as well, as per the theorem that we just learned. So if p is a prime number, if p divides a square, then p also divides a. That means uh, so therefore, I can say 2 also divides a. That means, can I say a as a 2 multiple? Some number c, 2c, right? So then just substitute this value of a equal to 2c. So 2c whole square by 2. That means 4c square by 2. That is b square. Then b square I can write as 2c square by, yeah, b square I can write as 2c square. Then c square I can write as b square by 2. So what is b square by 2? So here 2 is dividing b square. That means 2 also divides. Therefore, 2 also divides b, right? So here, what is a and b? A and b are the coprimes, and 2 is a prime number. So here, both a and b, though they are prime numbers, are having a common factor as 2 as per this, which is incorrect, right? So both coprimes, right? What are the coprimes? A and B has at least 2 as a common factor. But prime numbers do not have any other common factor, right, other than 1. So therefore, this this contradicts the fact. What is the fact? That the prime numbers do not have any common factors. Understood? Do not have any common factors. So why this is arising? Because we assumed that root 2 is rational. So that is incorrect. Therefore, our our assumption of root 2 as rational is wrong. Hence, root 2 is irrational. So basically, we are taking a contrary approach here. So root 2 is rational is what we need to prove. So what I am assuming as root 2 is rational, the contrary, exactly opposite to what we need to prove. So we know root 2 is irrational. So if I say it is rational, a rational number can be represented in the form of p by q. Here I took a by b. So root 2 is a by b. So if I simplify, if I square on both sides, then I can write b square as a square by 2. As per the earlier theorem, if 2 is dividing a square, 2 should also divide a, right? So that means a is multiples of 2. So a I substituted as 2 into c, the multiples of 2. So in place of a, if I substitute 2c, then it is 4c square by 2. Then c square I can write as b square by 2. That means 2 is also dividing b, right? That means a and b both are divisible by 2. What are A and B? A and B are the co-primes. So how can a prime numbers are divisible by 2? That is wrong. So why this is wrong? Because our assumption itself was wrong. So root 2 is a rational number is what we assumed. So that is wrong. So hence we can say that our assumption was wrong. Root 2 is a irrational number. Okay. So that's how we need to slightly take in the contrary approach and prove that. Okay, let's move on to the next. So that's prove that root 3 is irrational. It is same as before. So same as root 2. So let us assume what we will assume the contrary. That is root 3 is rational. So we assume root 3 is rational, which is the contrary to root 3 is irrational, which we already know root 3 is irrational. So how to prove that? So I have assumed root 3 as rational. So if root 3 is rational, I can write root 3 as a by b, where b is not equal to 0 and a comma b are co-primes. So both a and b are the prime numbers. Then I can write this as root 3b equal to a. If I square on both sides, then I can write 3b square as a square. That means I can write b square as a square by 3. That means 3 is dividing a square. That means 3 can also divide a, right? So here, therefore, 3 divides a as well, right? So if 3 is divisible, if a is divisible by 3, can I write a as 3c? I can write. In earlier case, it was 2c because it was divisible by 2. So now b square I can write as 3c whole square by 3. So b square is 9c square by 3. That is b square equal to 3c square. Then can I write c square as b square by 3? So what is happening here? 3 is dividing a square. So 3 is also divides a. And here 3 is also dividing b square. That means therefore 3 divides B as well. But what are these A and B? A and B are what? Co-primes. So the prime numbers. So here what we are getting, both A and B are divisible by 3, which is incorrect, right? So therefore, both A and B are having at least 3 as common factor. But this contradicts the fact. But this contradicts the fact. What was the fact? The fact that prime numbers do not have a common factor, do not have common factor other than 1, right? Common factor other than 1. So why this has arisen? Therefore, our assumption, so because we assumed that root 3 is rational, this A and B are, even though they are primes, they are getting a common factor of 3, which is incorrect. So therefore, our assumption of root 3 as rational is wrong. Hence, root 3 is irrational. Okay. Hope you understood. We did both root 2 and root 3. So you need to assume the contrary and then see like both A and B are having 3 as a common factor, which contradicts the actual fact that prime numbers do not have any factors other than 1. So our assumption of root 2 or root 3 is wrong. I mean root 2 or root 3 as rational number was wrong. So these are irrational numbers. Okay. Now let's look at this as well now. Show that 5 minus root 3 is irrational. See, 5 is an integer. Root 3 is an irrational number. If you subtract an irrational number from 5, the whole answer should also be an irrational number. So let's see how we can prove that. So same thing. Let us assume 5 minus root 3 is a rational number. Is a rational number. So we are following the contrary. So then, can I say 5 minus 3 is a rational number? Can I write as A by B, where B is not 0 and A and B are coprimes? Now, can I write this as, if I rearrange, can I write like 5 minus A by B as root 3, right? Then can I write root 3 as 5 into B minus A by B? So what are A and B? As A and B are coprimes, if I multiply with 5 and subtract a value, I still get some integer value. Integer by integer, I'll get a rational number. But what I'm getting here, root 3. But root 3, the value of. So as A and B are coprimes, right? Coprimes, 5b minus A by B is integer value, right? Integer. But root 3 is not an integer, right? So therefore, our assumption of 5 minus root 3 as rational is wrong. Because 5b minus A by A, 5b minus A by B. So these are coprime numbers. If I simplify these, I'll get a integer number. But root 3 is not an integer. So this is contradicting the fact that if we simplify whatever the values that we are getting. So what we can do? So we can say that our assumption was wrong. So since A and B are integers, we get 5 minus A by B as a rational. So this value as integer, which is a rational integer or a rational number, right? So, but this contradicts the fact that root 3 is irrational. So we can say this is a rational number. Our assumption of 5 minus root 3 rational was wrong. Therefore, 5 minus root 3 is irrational. This is how we can prove that these numbers are rational or irrational. So we looked at root 2, we looked at root 3, and now we looked at 5 minus root 3. 5 minus root 3, we just took as a rational number, we assume, and then 5 minus root 3, we can write as A by B. Then 5 minus A by B is root 3. Root 3 is 5B minus A by B. As A and B are the coprimes, if I simplify, I'll get an integer, which is a rational number. But root 3 is not rational number, right? Root 3 is irrational. We already know that. So this contradicts the fact that what we have, root 3 is irrational. Therefore, our assumption of 5 minus root 3 as a rational number was wrong. So 5 minus root 3 is a irrational number. Okay, so that's how we can do that. So that's all in today's session. So I hope you understood this topic, and I'll see you next time. If you have any questions or queries, you can contact me using my Urban Pro profile. Thank you.